Hi everyone, this is Mr. Hall and this is a really quick video about acids and bases. The content of this video is similar to what I have been through before about acids and metal carbonates and acids and metals. So if you've gone through those videos, this should be relatively straightforward, and it's very similar to work that you probably did when you were in Key Stage 3 as well. So the objectives of today's lesson are as follows. It's really similar to what we've discussed before, is to state the products from the reaction between an acid and a metal oxide or a hydroxide, which are bases. It's to predict the reactants or products in these reactions, and also, if you can, construct balanced symbol equations, which for me is the tricky bit. So let's get started. So first off, metal oxides and hydroxides are bases, all right, which means that they can neutralize acids. Now they're slightly different in terms of chemical formula and other sort of properties as well. And one of the main properties is that metal oxides tend to be insoluble, whereas metal hydroxides are soluble. So if we look at this example over here, this is copper oxide, which is like a black powder. And if you try to make copper sulfate, for example, by mixing it with sulfuric acid, you'll notice that the metal oxide will sort of collect at the bottom of the beaker like so. So what you can see here is the solution with the copper sulfate, blue crystals dissolved in it. And then this black powder is basically excess copper oxide because it can't dissolve, right? So metal oxides tend to be insoluble. They do not dissolve in water or solvents. However, metal hydroxides tend to be soluble, so if you put them in water, they will dissolve. And we have a word to describe bases which are soluble. We said they are alkalis, right? So that's the first thing. Now, when acids are neutralized by bases, they make a salt, as we've discussed before. And for metal oxides, when they react with acid, they form two things. They make a salt, and they also make water. Now, metal hydroxides do exactly the same thing. There's just a slight difference between metal oxides and metal hydroxides in terms of the ion that the metal is attached to. Now, in metal oxide, the ion is O2 minus. Now, O2 minus, it's basically an oxygen atom with 2 extra electrons on it in order to allow it to have a full outer shell. So if I draw sort of the first 2 shells of oxygen, so you can think like the first shell is 1, 2, and then it's got 3, 4, 5, 6, 7 and 8. Now that's normal oxygen. To make O2 minus, you need an extra 2 electrons. So I'm going to put one here and one here. That turns it into an ion because it's gained electrons, and because it's got gained 2 electrons, it is 2 minus. So that's oxide ion. Hydroxide is slightly different because now you've got an hydrogen attached to the oxygen. So if I was to draw an oxygen atom here, like so, and again I do my 1, 2, 3, 4, 5, 6, 7, and 8. Now the thing is that you've got a hydrogen atom bonded to it. Now let's draw the hydrogen atom here because it's a covalent bond because they're both non-metals. And then I'll draw the hydrogen electron there like so. And then if I do that, this is my hydrogen atom, this is my oxygen atom. The whole thing still needs 1 electron, so they all have full outer shells because the hydrogen's got a full outer shell because it's got the 2 over there. But this oxygen is lacking 1 electron here. So if I draw that extra electron there, that gives the whole thing a full outer shell, so it's stable, but it's gained an extra electron to do that, therefore it's just minus. So this is OH minus, and this is O2 minus. So just slightly different composition of the ions, which has an impact when you try to do balancing equations. Now, in terms of kind of predicting the names of the products, it's pretty much really similar to what you've done before with metal carbonates and metals reacting with acid. Now, the key thing to remember is that whether you have a metal oxide or a hydroxide, it doesn't matter in terms of word equations because the salt you produce is always going to be the same and you're always going to make water. It's just the compositions and numbers that slightly change. So if I look at zinc oxide and sulfuric acid, the first part of the name of my salt is derived from the zinc, which is the metal, and then the second part is from the acid bit, which is the sulfuric. Now, I always start with the last part though, which is the extra thing that you make. Now, in this particular case, I always make water if I react an acid with a base. Therefore, I always write this bit first, just because I know that's a reliable bit, that's never going to change. I then go to the name of the salt. So this bit is the salt here. Now, remember, in the first instance, I got zinc, so I can put that in first of all. And then the second part is sulfuric. And if you remember from previous learning, sulfuric acid makes sulfates, which goes there. So it's zinc sulfate plus water. Those are your products. And this is a typical word equation which just tells you the names of the reactants and products. So if we go through a couple more examples. Now, if you remember, hydrochloric acid makes chlorides, not hydrochloric or hydrochloride or something like that. Some people get the names mixed up because they don't remember. So again, I start with the last part, which is plus water. I then think of the name of the salt, which the first part is based on the name of the metal in the oxide, so let's just say magnesium oxide. So if that's the case, then the magnesium rather, goes over here. So magnesium is there, and then the chloric forms a chloride, which goes there. Okay, so that's pretty straightforward. For my next example here, where I've got sulfuric acid, now that makes sulfates. So in this example, again, I just put water first of all, because I know I always make that. And then for the salt, the first part is based on the metal, which is magnesium, which goes there. So I've got magnesium something. I've got sulfuric acid, which makes a sulfate, which goes there, okay? And those are your two products. And then finally, let's go through nitric acid, which can sometimes come up. Nitric acid forms nitrates. Again, I do the water bit first of all, because I know I'm always going to make that. And then I do the next two bits. Now I've got potassium hydroxide here. So the potassium goes there, because that's my metal. And then the second part is from the nitric, which, as we know, forms nitrates. So I form potassium nitrate. So that's some examples of how you formulate the word equations. Now, what you might want to do is just sort of pause the video really quickly just to go through some examples independently. I'll just zoom through these really quickly for your benefit, but feel free to pause it if you find it helpful. The first thing I do is I always write down just plus water, because I know I'm always going to make water in these examples. And then that just isolates me having to work out the name of the salt, which I can sort of do quite happily on my own. So the first part is based on the metal. Here I've got magnesium oxide. So the first part of the name rather, for this salt is magnesium, and I'll work out the second bit, which is based on the acid, which is sulfate. Over here it's sodium, because that's the name of the metal. And I've got hydrochloric acid, which is a chloride, so sodium chloride. Here I've got copper oxide, so the first part of the name of the salt is copper. It's nitric acid, so I make copper nitrate. Here I've got zinc hydroxide plus sulfuric acid, so it's zinc, because that's the name of the metal. And then sulfuric makes sulfates. And then finally I've got iron oxide plus nitric acid, which makes iron, and then nitrate. And that's how you construct it. So you can see that once you get really adept at this, it becomes quite a quick and straightforward process of predicting it. You just have to practice. Practice makes perfect. Now, the symbol equations is a trickier thing, because we know that metal oxides and hydroxides, when they react with acid, make a salt and water, and the products look the same. So how are they different in terms of composition? Why is it they look exactly the same in terms of reaction? And the key to really doing this is by looking at the formula of the symbols, or rather looking at the symbol equations to work out how they are different. And it's probably best doing this by going through a couple of examples. Now, the example that we're going to look at is calcium oxide or calcium hydroxide reacting with sulfuric acid. You'll see that they tend to make the same products. Ooh, I'll just go back. They make the same products, but it's the numbers of each which completely change. So let's have a look at this in more depth. Now, this is quite hard, so I'll try and go through this as sort of steadily as I can. First off, we need to know the formulae of sulfuric acid, and you do have to remember this as well as the other acids. Sulfuric acid is H2SO4, all right? So I'll write this for both of them just because we're going to come back to it a little bit later on. Now, the harder bit, let's do it before there, is thinking about the formulae for the oxides and the hydroxide. Now, calcium is in group 2. That means it's got 2 electrons in the outer shell. If it wants to form an ion, it needs to get rid of those 2 electrons. So the ion for calcium is Ca2+. Okay. Oxide, obviously oxygen, we know the oxide ion is O2-. Now, because they've got the same charges, if you were to kind of put this on a little seesaw, you've got calcium with 2+, oxide of 2-, and because they've got the same number of plus and minus on either side, they form a neutral salt. As a result, it's just CaO, or say neutral ionic substance, so it's CaO, because you just need one of each. Now that forms calcium sulfate plus water. Now we know water is H2O, so that's the easy bit. Calcium sulfate's a bit trickier. Calcium, as we recall, is 2+ because it's in group 2. Sulfate is SO4 2-. Again, this is something that's definitely worth remembering. And again, if I kind of put this on a seesaw, I've got the 2 pluses here, and from the 2 minus on the sulfite ion, that goes over here. So you can see, again, they both balance out. So therefore, the formula is CaSO4. Now, if I was to do a quick bit of balancing, let's just double check how many atoms we've got on either side. 1 calcium here, 1 calcium here, that looks balanced. 2 hydrogens over on the left, 2 hydrogens on the right, that's balanced. Now for sulfur, 1 over here, 1 over here, balanced. Oxygen, I've got 4 and 1 is 5, 4 and 1 is 5, balanced. So that equation is balanced. So 1 sort of mole of sulfuric acid reacts with 1 mole of calcium oxide to form 1 mole of calcium sulfate and 1 mole of hydrogen. Now let's have a look if we do it with calcium hydroxide. Now let's think about the formula for calcium hydroxide. Now we know that calcium is Ca2+, but hydroxide is OH-. Now if I put that on a little sort of seesaw, I've got the 2 plus from the calcium, and I've got 1 minus from the OH minus. Now you can see that that doesn't work because I've got 2 pluses to 1 minus. So I need another minus in order to balance everything out, to have 2 on the left and 2 on the right, to have a neutral ionic salt. But that means I also have another OH. So the formula here, and this is quite tricky because you've got CaOH, but I need 2 OHs. So I have to put that in brackets and then put 2 as a subscript, and that tells me I've got the 2 hydroxide ions stuck onto the calcium. Now that makes the same product as before, and I'm not going to go for that process again. You can rewind the video if you have to. But that makes calcium sulfate, which is CaSO4, plus H2O. Now if you look at this really carefully, let's do the balancing to work out what's going on. 1 calcium to 1 calcium, balanced. 1 sulfur to 1 sulfur, balanced. Now if you look at hydrogen, this is where it gets a bit trickier. 2 hydrogens here, and then 2 hydrogens here, because you've got 1 there, but times by 2. So you've got 4 hydrogens in total, but only 2 over here. So to balance that, I need to get 2 water molecules. And then if you check the oxygen, 4 plus 2, because you've got 1 lot of 2 makes 6, 4, and now 2, because it's 2 lots of 1, also makes 6. So those are balanced as well. So the big difference here is that the formula of your reactant is slightly different, and also the number of water molecules you produce is slightly different. And it's basically because your metal hydroxide has more stuff on it than the calcium oxide to begin with. And that's it. So I hope that video is quite helpful, and best of luck with working out your acid-base reactions.